Okay, so like function notation, this thing that we're about to investigate here is another really useful tool, especially in building animations. So we want to understand it really well. I've graphed the 2 points A and B, and I have this construct right here. 1 minus t times A plus t times B. So let's talk about t. T is reserved in GC as what's called a parameter. And what did we say a parameter was? How did we define it? What's that?
A number that doesn't change.
Yeah, a number that doesn't change. Okay, so this is, in this case, so it's going to take on one value at a time, but it's not that t increases from 0 to 1. It's going to take on all these different values simultaneously. So we still think of a parameter as representing one situation. It's not going to change. But now this, in GC, it's going to spray a bunch of different values of t simultaneously. Okay? So we still want to think of it as a parameter. It's not varying from 0 to 1. It's just taking on all the values from 0 to 1 individually. And so when I turn this on, it's going to simultaneously graph whatever it's going to graph for all the values of t between 0 and 1. Does it make sense? So your job is, without putting this into GC and just turning it on, is at your tables, is to figure out what you're going to see when I turn that line on. So what will this graph? If t is going to be all the values from 0 to 1 kind of at once. That's what this says over here. All the values t from 0 to 1 graphed, and we're going to graphed all at once. So then what will graph? What will the graph be? When I turn that line on. So you should talk and maybe get out your pen and paper and write some things. Figure it out. What will the graph be when I turn that on?
We plugged in 0, and we plugged in 1, and we plugged in 0.5.
Okay, so not plugging things in, but algebra on this. Did anyone read?
We also did a line.
Yeah, Kelly, tell me.
We distribute A.
Okay. And what'd you get?
A minus A.
Okay.
Or plus T.
Okay.
And then we factored out the T.
Okay. And you got?
A minus T.
Can I say plus?
Minus.
Okay. Minus. Oh, bye. Okay, so you got A minus what?
T.
Yeah?
Parentheses A minus B.
So we do plus instead? So how about A plus T times B minus A? All right, so you got some here. This is equivalent to that. By algebra, those two are equivalent. So that might give you something more to think about, or verify what some of you came up with, or maybe take a new track.
Oh.
So what's going on?
Oh my God.
Hey, you guys, t isn't a constant of change. T is all the numbers between 0 and 1, right? So all the numbers from 0 to 1.
Okay. Because algebra and time. Have you taken linear algebra yet at school? My favorite class. Take it with Theo Cruz. I might text you later.
Okay. So either you're verifying what you came up with, or you're Throwing out some old ideas and trying some new ones. A couple ruins. Yeah, this is a great question. So what does the number 4 represent and the number 6 represent? Is it a point? Is it the point 46? So when you do b minus a, are you getting a new point 46, or does it mean something else? Where does 4 and 6? Where does 4, 6 come into this situation? So where's the point 46? Here's the point 46. Is that relevant? So what do those numbers 4 and 6 mean? So how do we get the 4? 7 minus 3. So what does 4 represent here? Brandon, tell me. Change in x from A to B, right? Change of 4, right? And the 7 or 6? Change in y. So what are we doing? We're multiplying t, some number between 0 and 1. This is kind of some, fraction of these changes, right? So like 0.5, you're going to take half of those changes. If it's 0.1, you're going to take a tenth of those changes and add it to what? The coordinates of A, right? The coordinates of A. So what would you get? Does that make sense? What color? Okay, so in terms of the way we just reasoned it, I think it's easier to see it in this form. But this form, so what is this really doing? It's really giving us kind of the transition from A to B, right? So it's giving us every point in transition from the point A to the point B in a linear fashion. Starting point, final point, okay? Now, so this isn't normally the form we use to do. We normally use this form, but this kind of helps us see what's happening, right? Starting at point A, we're always adding some fraction of the change, the total change from B to A. Does that make sense? Okay, so another example of this. You don't have, it doesn't work with just points. It works with all kinds of things. Okay, so here is let's turn off this. All this. So I got a function f of x there. And a function g of x. So I'm going to graph g of x. So here's the function g of x, red, okay? And now, right now I have n set to 0, okay? So when n right now is the slider, and it's set to 0. What if I turn on that line right there by the arrow, with n set to 0, what's it going to graph? Talk to your tables. I'm going to just turn it on with n set to 0. What's the graph going to show? Go. N is 0. When I turn this on, what's it going to show? What do you think? Rachel? Jesus, what do you think? G of x. So if I turn it on blue, we'll get blue plus red is indigo. No, indigo. So all right. Now, I'm going to change n one value at a time. So before the parameter t, it just sprayed all the values from 0 to 1 at once when we graph that 1 minus t line. But now I'm going to take these one at a time because the slider n only allows me to do one at a time. So when I change the slider, what are you going to see? Go. Talk. All right, should I play it? Ready? What's going to happen? So I think most of you got the idea. What's going to happen? You guys gonna vote for Brandon? You guys gonna vote for
We were saying it's going to stay there, and then as n increases,
Mhm.
it's going to start to slow. It's going to like we don't know what it's going to do exactly, but it's going to slowly start to go into f or become f of x.
become f of x. So when n reaches 1, it is f of x, right? N is 0.5 right now. Now n is 0.8, and then 1. That's what I was going for. Blanket. No, that's... So this is this idea here that so it doesn't. So I showed you an example where it did it with points. So what if I wanted to show like a moving point from point A to point B? How would I change? How would I change this right here? If I wanted, instead of spraying all the points at once, I wanted to show the moving point. Yeah. Point moving from A to B. Yeah. So instead of, when I turn that one on, right, when I do 1 minus TA, TB, it showed me all the points, right? T for all values between 0 and 1. How would I show a moving point from A to B? Individual point moving from A to B. Yeah, you just change the T to N, right? Change the T to N. Okay. So this idea, say x times 1 minus t plus y. This doesn't have to be any particular thing, right? So I showed you this. This could be a point. These x and y could be points. They could be functions. Okay, they could be other things too. Segments. There's lots of different things this x and y could take on, and then when you use this construct, what do you get? You get the linear transformation from x to y. And if you use t, you're going to get them all at once. You should get to see them all at once. If you use n, then you're controlling which one you're going to see. If you use n, again, from 0 to 1, right? So you always want this to be from 0 to 1.
So what if we were to put T in for that
Okay,
function?
great question. I'm going to put t, she wants me to put t in to this blue line, 1 minus t gx plus t fx. What will we see?
All the points from that thing to the line.
Well, and what will that look like?
Like inequality from in between g of x and f of x.
I think this will work. I'm not positive. So, what are you going to see? Or what should we see? What does it represent? Whether GC does it or not? The shaded area between the two, right? Everything between the two. So we cross our fingers. What color do you want? Pink. I can do that. You laugh. Work. Oh, didn't like it. Oh. So it's saying it only can be used in parametric curves, right? So this is like now like a region. It's like, but we know what it should be.
What if they restrict it to a certain x value?
So really what we're graphing, I mean, what that represents though is everything in between. So it would be what? G of x.
It's gonna be f of x minus g of x.
So how can we get that shaded area? G of x less than y is less than.
What if we just
You want orange.
minus g of x?
You're gonna get your orange.
It reminds me of Nickelodeon.
Oh gosh. Does it still work if you do f of x minus g of x?
What's that?
Does it still work if you do f of x minus g of x? Or is that
No, that will just that gives you a new function, right? It'll give you a new function of the change from G to F at any value of X. So that's just a new function. It doesn't represent all the points. Question?
Well, I was gonna say the question sort of does it represent the points that
So f of x minus g of x will be a new function that when you plug in x, you get the change from G to F. So it'll graph a string of points that each one of those, now the y values of this function are how much change there is from G to F for each value of x. Does that make sense?
So it'd be lines from.
No. It's still a set of points. It's just for every x value, you're going to get one y value, and that y value will represent how much change there is from G to F.
Oh, so it's just gonna be a string of points that are.
It'll be a new
equal
curve.
to
Yeah, let's do it. So y
equals
equals,
f of x minus g of x.
yeah.
Why not?
Be the amount of change.
Oh wow. That's completely different.
So each y value there is the change, the amount of change between the y values of the original two functions.
That's crazy.
Okay, so homework for Tuesday.